So now we are going to do question 9. We are given f of x being equals to 2x cubed minus 3x squared minus 72x minus 35. And we are given point A of the cubic function here, and we're given B and C, which are the points here. They're indicated as the x-intercepts, and we're given D and E, which are the turning points of our cubic function. So another one here, right? So the first question says that we must identify the coordinates of B and C. So the coordinates of B and C, so for us to find the coordinates of B and C, we need to know what B and C is. B and C are the x-intercepts of the cubic function. So for us to find them, we already know the y values here are actually 0, y is equals to 0 here, and y is equals to 0. So we need to know what the value of x is when y is 0. So for us to find, we need to use this equation here for us to find the coordinates of B and C, right? So what I'm going to do is I'm going to factorize it. But we can't just factorize it. So you have 2x cubed minus 3x squared minus 72x minus 35, right? So we need to first factorize this expression here. So for us to factorize this expression here, we need to equate f of x to 0, right? So 0 is equals to 2x cubed minus 3x squared minus 72x minus 35, right? So for us to factorize this expression here, we also need to substitute a value here where there's x. We need to find a value of x such that when we substitute, it gives us a solution of 0, right? So you're going to test x is equals to 1. So meaning you're going to substitute x equals to 1 where there's x and see if it's going to give you 0. Kuba umsindo man. Tshela mama kuba umsindo. So when x is equals to 1, you need to substitute that x equals to 1 where there's x and see if it's going to give you 0. If it doesn't give you 0, try substituting x equals to minus 1. If it also doesn't give you 0, try substituting x equals to 2 or x equals to minus 2, x equals to 3, or x equals to minus 3, right? Just try and substitute the values of x where there's x here and see if it's going to give you a solution equals to 0. So I found that x equals to minus 5 does give you 0. So if you substitute x being equals to minus 5 in this expression here, it will give you 0. So that means that x equals to minus 5 is going to be our factor. So writing it in factor format, it's x plus 5, right? Because we take the minus 5 to the other side. So this is our factor. So it's critical for us to find the factor because it will help us factorizing this problem here. So now we know our factor. So our factor is x plus 5, right? Which is x equals to minus 5, right? So we can factorize our expression. Our expression of f of x is equal to 2x cubed minus 3x squared minus 72x minus 35, right? So for us to factorize, we're going to use this method here, where our x is equals to minus 5. And then we're going to write the coefficients. All these coefficients, we're just going to write them. And then we're going to write that 35 here, minus 35. So the first coefficient is 2, the second one is minus 3, the third one is minus 72, and then minus 35. So remember, I'm just writing these coefficients here, and then this minus 35. Then we're going to start at 0, so you always write 0. And then you add, so that's why I'm going to write plus here. So we're going to say 2 plus 0 is 2. And then this 2 multiplied by this 5 here, minus 5 rather, is going to give us minus 10, right? Did you get that? This 2 plus 0 gives us 2. 2 multiplied by minus 5 gives us minus 10. And then you repeat the process. And then you're going to repeat the process and say minus 3 plus minus 10 gives you minus 13, right? Minus 13 times this minus 5, it's going to give you plus 65, because it's minus times minus. And then minus 72 plus 65, it will give you minus 7. Minus 7 times minus 5 should give you 35. And then minus 35 plus 35 should give you 0. So you must always get 0 at the end. This tells you that the remainder, this is the remainder. The remainder must always be equals to 0, right? In this method here, so that you know that you did the method correctly. So once you are done, this expression here is your parabola. This is your parabola expression, and this is your factor, right? So your factor is x plus 5, and then your parabola, which is x squared, ax squared plus bx plus c, right? And what is your value of a? This first value, which is 2, it's your value of a. A is equals to 2, and this 13, it's your b. B is equals to minus 13, and your c is equals to minus 7. So you're just going to substitute here all these values that I just mentioned. You substitute them there. So you're going to have x plus 5, and our a is 2, so it's going to be 2x squared. Our b is minus 13, so it's minus 13x, and our c is minus 7. So that is your expression there. So now we need to factorize this parabola here. So it's going to be x plus 5, and then we factorize the parabola, so it's going to be 2x and an x there, and 1 and 7 there, so it's going to be minus and a plus. So now we factorize this expression. We know it's equals to 0, right? So we're just going to equate to 0. So it's going to be x plus 5 equals to 0, or 2x plus 1 equals to 0, or x minus 7 equals to 0. Remember, we want to find the coordinates of b and c. So here it's going to be x equals to minus 5, or here it's going to be 2x equals to minus 1, or x equals to 7. So here we're just going to divide by 2 both sides. So it's going to be x equals to minus 1 over 2. So these are your solutions of x, right? But we want the coordinates of b and c. So for us to find the coordinates of b and c, we have to go back to our diagram, and note that we found the x-intercept to be x being equals to minus 5, and x being equals to minus 1 over 2, and x being equals to 7, right? So with these, they'll tell us where our b is and where our c is. So x being equals to minus 5, it's this point here, so we don't need it, so I'm just going to cancel it out. And x being equals to minus 1 over 2, and x being equals to 7. X being equals to minus 1 over 2, it tells us that it's actually this point here, right? So our b would be minus 1 over 2 and 0. And then x being equals to 7, it's this point here. So our c is going to be 7 and 0. So these are our coordinates of b and c. Now we are going to do 9.2, where we are asked to find the coordinates of d and e, right? So for us to find those coordinates, we're going to go back to this equation, right, of f of x. So this is the equation, and d and e are the turning points. So basically what it means is we need to find the derivative of this f of x, right? So we have f of x being equals to 2x cubed minus 3x squared minus 72x minus 35, right? So because we want to find the coordinates of D and E, we need to derive this expression because those coordinates are turning points. So it's going to be 6x squared minus 6x minus 72, right? And then we equate the derivative to 0. So it's going to be 0 is equals to 6x squared minus 6x minus 72. And we divide by 6 both sides, and we'll have 0 is equals to x squared minus x minus 12. And then we factorize, we have x and x there, we have 6. We can't use 6 and 2 because the middle term is 1. So we're going to use 4 and 3, right? So it's going to be minus 4 and plus 3 there. And then x will be equals to minus 3, or x being equals to 4. So we have the x value of the turning points. Now we want to find the y values of the turning point. So you're going to substitute at f of x, alright, in your f of x equation. So it's going to say f of x of minus 3. So when you substitute it into the original equation, as I said, so f of x is equals to 2x cubed minus 3x squared minus 72x minus 35. So you're going to substitute in this equation here your value of x. You're going to substitute it here, here, and there, right? And you should find 100 if you substitute x being equals to minus 3. If you substitute x equals to 4, you should find minus 243, right? So these are our coordinates of the turning point. But now we need to know which one is the coordinate for D and which one is the coordinate for E. So we're just gonna go to our diagram and see which one belongs to which. So we know the x values of the turning point, x being equals to minus 3 or x being equals to 4, and the y values we found y being equals to 100 for this one, and y being equals to minus 243, right? So for D, you can see that D is actually where x is equals to minus 3, right? And then here x is equals to 4. So we can confirm now that the coordinates for D would be minus 3 and 100, and then the coordinates for E would be 4 and minus 243. So these are the coordinates of D and E. So we're going to do 9.3. 9.3 says that for which values of x will the graph be concave down? So when you talk of concave down, this is concave up, this is concave down, right? Concave up, concave down, right? So we need to note the value of x when the function does that. But we can tell from this graph which one is concave down, which one's concave up, right? So this is concave down, right? Concave down, and this is concave up. So we want to note the value of x when the function is concave down. So what defines the concavity of a cubic function is the second derivative, which is the point of inflection, right? So we need to find that second derivative of this f of x here. So we have f of x being equals to 2x cubed minus 3x squared minus 72x minus 35, right? Just going to write it properly this side here. So we have So we have f of x being equals to 2x cubed minus 3x squared minus 72x minus 35, right? And we found the first derivative from previous question to be 6x squared minus 6x minus 72, right? And I said the point of inflection is the second derivative, so we'll find the second derivative, which is equals to 12x minus 6, right? And we have to equate the second derivative to 0, so it's going to be 12x minus 6 equals to 0. Transpose the 6 to the other side, you have 12x equals to 6, and then we find the value of x, so divide by 12, divide by 12, x is equals to 1 over 2, right? So we have found the value of x, of the points of inflection, so now we can interpret using our graph. So where is the graph concave down? So it's concave down here. I indicated with this color. So so it's concave down here, as I indicated with the arrows. So now we found x being equals to 1 over 2, right? Which can be somewhere here. X being equals to 1 over 2 can be somewhere here. 1 over 2. So now we need to interpret it with respect to the concave down. So concave down is before 1 over 2. So it's that direction, right? It's not going down, it's going up. So to conclude, we can say when x is less than 1 over 2, when x is less than 1 over 2, the function is concave down. So if you look up, when x is less than 1 over 2, less than 1 over 2 is that direction, right? So when x is less than 1 over 2, the function is concave down. So that is the solution, x being less than 1 over 2. Now we're going to do 9.4, where we are asked, determine the values of x such that when you multiply the f of x with its derivative, you're getting a solution that is greater or equals to 0. So make sure that your x value is less than 0. So okay, we go back to our f of x, right? This is our f of x, and we are told that when you multiply the f of x with its derivative, your solution must be greater or equals to 0, right? Yes. So where does that happen? So we're going to look at this function here, and as I said, this is f of x, and the derivative, it just tells you the flow of the function, the gradient. The derivative is the gradient. It's the gradient, right? So if you are going to start at this point and you say this arrow here, so this side of the cubic function, the gradient is increasing, right? The gradient is positive gradient, right? So if you multiply the positive gradient with this value of y, so what are the values of y from, let me just say, from this point of A going down, right? Just this portion here. The values of y are negative, right? Let me just indicate that values of y are negative. Values of y values are negative. So if you multiply this negative with this positive, you're going to get a negative, right? Positive times negative equals to negative. So that's not what we are looking for. We are looking for a situation where we multiply a positive times a positive, we get a positive. Or we multiply a negative times a negative, we get a positive, right? So so this case doesn't work. So we're going to look at the top, not here at the bottom. If we look at the top of this cubic function here, it's still increasing, right? The function is still increasing here. It's still increasing, so it's positive. And the y values are also positive here. So the y values are positive, 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 up until this point here. So you can include this point. You can include it and say that when you multiply the positive with the positive, it gives you a positive solution, which is what we are looking for, right? We're looking for a positive solution. So this is inclusive. It is part of our solution. And then let's try out here. So if you multiply, so here the gradient is decreasing, so it's negative, 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 negative. But the y values are positive, 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 positive. So this will not work because the positive times a negative gives us a negative. So this doesn't work. And then we try out here. So the gradient, or the y values rather, are negative at this point. So it's negative, 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 negative. So the y values are negative, and the gradient is decreasing. So it's negative, 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 negative. So this works because if you multiply a negative and a negative, it gives you a positive. So this works. Let's try this section of the graph. The gradient is positive here. It's increasing, 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 increasing. And then the y values are negative, 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 negative. So this won't work. Won't consider it. This one won't work. So I'm just going to cancel it out like that. And let's try out here. So the gradient is still positive, 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 positive. The y values are positive, 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 positive. So this one works. So this works, and this works, and this works. So you see, it's 3 points that work. So that's how you're going to interpret your x values, right? You should need to remember the x value of the turning point here of D. So you can simply say, if you interpret this section here, this section where I take the correct for this one here, you know the x value here, it's x being equals to minus 5. You know the x value of D, it's x being equals to minus 2, right? So you can say x must lie between minus 5 and minus 2. So this first solution of x would be correct. And then if you look at another one, which is this point here where I ticked, x at B is equals to minus 1 over 2, right? And then at E, x is equals to So before we conclude our values of x, let's first find the x values at these points. So at A, x is equals to minus 5. At D, x is equals to minus 3. At E, x is equals to 2. At E, x is equals to 4, and at B, x is equals to minus 1 over 2. Then at C, x is equals to 7. So I'm sorry with a lot of working here. So I hope you follow. So now we're going to look where I tick. So I tick here. This works for us because we want where the gradient multiplied by the y values give us a positive solution. So this works. And this works also with the gradient multiplied by the y values, they give us a positive solution, and also this one works. So where I ticked are where cases they're working, where we can find our solutions of x, right? So starting with this one, where this portion here where I ticked. So we're going to say when x lies between -3 and -5. When x lies between -3 and -5, we are getting a situation where the gradient multiplied by f of x is greater or equal to 0. Right? So this portion here is correct. And then we try out this one here also, where we can start off from B going to E. So we can say when x lies between -1/2 and 4. So this one is also correct. So if you write this or you write this, it will be correct. Or we try out this one here, and we can simply say because here at point C, x is equal to 7 and then up to infinity, right? So we can simply say when x is between 7, so I'm going to write 7 here. We're not going to say it equals to, because we don't know the infinity. So up to infinity, that's where now you get the situation where you multiply the gradient and the y values gives you a positive solution or equal to 0. So you can write either of the three solutions of x, you would be correct, right? But even if you write solutions of x that are different to this, but as long as they lie between these values that I've just given, then your answer should be correct.